So in the last video, I left you with the question, what would the probability of picking 5 red and 2 blue counters out of the bag? Remembering obviously that there were 5 red and 3 blue counters in the bag, so another probability of picking a red and a blue. But we were going to do this 7 times, so that's picking a counter out, recording it, replacing it and doing that 7 times. Now if you imagine a tree diagram, that tree diagram would have had 7 different levels, and it would be almost impossible to actually draw out. So what I did was I looked at something that we started to look at in the last video and actually wrote out all the possible combinations. Now if you remember, I gave the idea of maybe having picking a red and not a red, in the idea that a pass would be picking a red and a fail would be picking not a red. Okay. So with 7 picks from the bag, I worked out that these were all the possible combinations. And you can see I've applied a little bit of logic to it, how the non-reds move through the pickings circuit. And you can see that there are quite a large number of outcomes. And it's obviously very difficult to make sure you've got them all. In fact, there are actually 21 outcomes, which means in terms of a tree diagram, you would have to look at the 21 individual branches that would take you through 5 reds and 2 non-reds being picked. Obviously, there would be many, many more branches that you wouldn't be interested in. So what we know then is, from actually doing all this, is that there are 21 branches, okay, that we would need to follow. However, we do know that the probability of getting a red was 5/8 and getting a blue was 3/8. And we know generally that obviously there are 21 branches. We know by the fact of multiplication that if we take the top row there, 5 reds, that would be 5/8 to the power 5. And then obviously we would have 3/8 to the power 2. It doesn't matter how we rearrange those, we'd always get the same answer of 5 reds being picked and 2 blues being picked, 2 non-reds being picked. It's just we're doing it 21 times. So, and then doing that calculation will give us the probability of picking out 5 reds and 2 blues in any order. So obviously these 2 parts are fairly self-explanatory. It's the 21 that interests me now, because obviously if I was then to say, okay, we're going to have 8 goes now and I want to get 6 reds and 2 blues, we're going to have even more branches of the tree diagram. So how are we going to do that? Because obviously there's a system, and usually in maths where there's a system, there's an easier way. And of course there is. In this case here, we're going to use a button on our calculator called the NCR button, okay? And this is what we call the combinations. Now in this case, we had 7 picks from the bag. So our number of picks would be 7. Our R value is going to be our number of successes. And in this case, our idea of success is picking a red, which is 5. So on our calculator, we could do 7, choose 5. And that will allow us, the calculator will then calculate how many ways you can pick 5 reds from 7 picks. And if you put that in your calculator, you will get 21. Similarly, if I wanted to find from 10 picks, 8 reds and 2 non-reds, I'd do 10, choose 8. So the choose method is actually a really good way of actually finding how many branches you need to investigate of the tree diagram, rather than listing all the outcomes, because obviously as it gets more and more complex, the chances of you actually missing one of the combinations is going to be very high. So now we've got an idea of how we get the number of branches. We kind of see how we have our successes and also our failures. So this leads us nicely into something that we've been discussing here, is called the binomial distribution. And the thing with the binomial distribution, it's fairly straightforward. The key points are we have to have a pass or a fail. There has to always be 2 outcomes. And also the outcomes have to be independent of each other. Okay, so they have to be independent events. Essentially, that means exactly the same as when we have a tree diagram. The fact that I picked 1 red out of the bag and put it back in has no effect on the probability of me picking another red out. Everything is an independent event. As long as we keep those 2 main things in mind, we can always recognise